Okay, we're going to continue with 2.4 and talk more on slope. So we're going to look at the slope and parallel lines. If two non-vertical lines are parallel, then they have the same slope. If two distinct non-vertical lines have the same slope, then they are parallel. So those two are the opposite. So if you have the same slope, the lines are parallel. If they are parallel, they have the same slope. And notice that we've been talking about non-vertical lines. So on this third one, two distinct vertical lines, both with undefined slope, are parallel. So remember that for vertical lines, the slope is undefined. Okay, so we're going to look at an example here, writing equations of a line parallel to a given line. So we are supposed to write an equation of the line passing through point -2, 5, and parallel to the line whose equation is y equals 3x plus 1. Express the equation in a point slope form and slope intercept form. So we need two different forms here. Okay, what do we know? If it is parallel to this line, the slope is going to be the same. And the slope for this is 3 right here. So we know that the slope is going to be 3. Then we have a point that the line is going to be passing through. So x1, y1 ordered pair is going to be -2, 5. Okay, first we're going to do the point slope form because we have a point and we have a slope. So a reminder, the point slope form is y minus y1 equals m times x minus x1 inside parentheses. So we're going to go ahead and plug in y minus y1 is 5, m, the slope is 3, x minus x1, which is -2. And all we're going to do for the point slope form is we're going to distribute this negative sign over here. So we're going to rewrite it as y minus 5 equals 3 times x plus 2 inside parentheses. So that is your point slope form. Now we're going to do the slope intercept form, which is the y equals mx plus b. So what we need to do is we're going to take the point slope form here, and first we need to distribute the 3. So y minus 5 equals 3x plus 6. And then we are isolating the y because if we look at this form right here, the y is by itself on the left. So we're going to add 5 to both sides, and it's y equals 3x plus 11. So that is your slope intercept form. Okay, so this was for parallel lines. Next, what we're going to do is look at slope and perpendicular lines. So if two non-vertical lines are perpendicular, then the product of their slopes is -1. So perpendicular lines are in a 90-degree line. Actually, I didn't do that for the parallel lines. So parallel lines are the lines that are going the same way, they never touch each other. So perpendicular lines are in 90-degree angle to each other. So their product of their slopes is always -1. Now, the other way around, if the product of the slopes of two lines is -1, then the lines are perpendicular. Now, a horizontal line having 0 slope is perpendicular to a, so if we think about a horizontal line here, this is a horizontal line, a perpendicular line would be a vertical. So it is perpendicular to a vertical line having undefined slope. So the horizontal line slope is, so this is 0, and the vertical line has the undefined slope. Okay, next we're going to write equations of a line perpendicular to a given line. So we are given equation x plus 3y minus 12 equals 0. For us to know what the slope is we're going to have to put it into the slope-intercept form. So we're going to have to move everything except y to the right. So I'm going to add the 12 to both sides, and it really doesn't matter. We could move the x at the same time, but I decided to do it this way. So I'm going to subtract x from both sides to cancel that out. So 3y equals negative x plus 12. Then we are dividing by 3. All of them. So y equals negative 1/3 x. 12 divided by 3 is 4. Okay, now our slope is going to be negative 1/3 for this line. Now, if we want a perpendicular slope, what we are going to do is we're going to take the negative 1/3. We are taking the reciprocal, so we're flipping it over and switching the sign. So it ends up being 3 over 1 a plus, which this is 3. So the perpendicular slope is 3. Now, what we should do is check. Remember, the slopes of these lines are going to be -1, or the product of the slopes are -1. So negative 1/3 times 3 is going to be negative 3 over 3, which is -1, which is correct. So what did we do here? We changed the sign and took the reciprocal, so flipped it over. So if our sign is a positive, it's going to be a negative, but in our case, it's a negative, so that's why we change it into a positive. Okay, now we're gonna, so this was all we needed for this one, was the slope. Now we're going to write the equation of the line passing through -2, -6, and a perpendicular to the line whose equation is x plus 3y minus 12, and the 0 is on the next line here. Okay, this is the exact same line that we just did with the example, so we can just say from the previous example that m equals 3, because we already calculate the slope on the previous example. Okay, so we have the slope and we have a point, so we're going to use the point slope form first. So that is the y minus y1 equals m times x minus x1 inside parentheses. So y and our x1 and y1 are these right here. So y minus -6 equals, our slope is 3, x minus -2. The negatives become a positive. These negatives become a positive as well. Now, what we want to do, so it's asking us to write it in general form. Remember, the general form is ax plus by plus c equals 0. So we're going to have to first distribute the 3, so we get y plus 6 equals 3x plus 6. Now, we need to move everything to the left. So I'm going to go ahead and subtract 6 first. Well, it cancels it out on both sides. Now, we're going to subtract 3x from this, and we get y minus 3x equals 0. So if we look at our general form here, our x is first, then it's our y, we don't have a c, and equal to 0. Now, what we want to do every single time with the general form, we need the a, or the a should be positive. So what we're going to do here is we're actually going to multiply this whole thing by -1. When we do the whole, like we multiply both sides by -1, we're not changing the equation. So, actually, what I'm doing is like this. So -1 times -3x is going to be a positive 3x. So we get the positive a. -1 times y is going to be -y, and 0 times -1 is going to stay as 0. So this is our answer. Again, the a should be a positive. Here, that is why we multiplied both sides by -1. Okay, next we're going to look at slope as a rate of change. Remember, it's rise over run, and that's what we're going to be talking about. So slope is defined as the ratio of the change in y to a corresponding change in x. This is the rise, and this is the run. It describes how fast y is changing with respect to x. For a linear function, slope, so a line, may be interpreted as the rate of change of the dependent variable per unit change in the independent variable. Dependent is y and independent is x. Again, reminder that slope, actually, slope is rise over run. That's the change in y over change in x. Y2, hold on, y2 minus y1 over x2 minus x1. There we go. That's slope. Okay, so let's look at an example. Slope as rate of change. In 2000, 11.9 million young adults lived with their parents. In 2017, 22.0 million young adults lived with their parents. Use this information to find the slope of the linear function representing young adults living with their parents. Express the slope correct to 2 decimal places and describe what it represents. So, slope, linear function representing young adults living with their parents. So we need 2 points, x and y. And now, X is usually always has something to do with time. So if there is a time, X is going to be the time. So right here, we're going to drop the million and just use the 11.9. Now we just need to make sure that when we write it, our answer, we remember that it's millions. So the time here is going to be 2000. And so that's our X, and our Y is going to be 11.9. So this is our X1, Y1. Our X2, Y2 is going to be the other one, 2017 and 22 million. But we're dropping the million for now. So we're just using this right here. Okay, so let's go ahead and calculate the slope. So Y2 is 22, Y1 is 11.9, X2 is 2017, and X1 is 2000. And again, remember that when you're doing this on a calculator, if you're plugging the whole thing in, you have to put parentheses um, or do the subtractions first. Now, express the slope correct to 2 decimal places. So the 2 decimal places would be 0.59. And then it's asking us to describe um, what it represents. Well, before we start describing, remember that we had 1 million here. So so this is actually not 0.59, it's 0.59 million. So when we start moving the decimal here, million is the same thing as it has 6 zeros, right? So we're going to move this decimal 6 times. 1, 2, 3, 4, 5, 6. It's just like we would be multiplying by a million. So we get 590,000. Okay, so now we need to interpret this. So the number of young adults living with parents. Now, again, slope is rate of change, and this is our slope. It's a positive slope, so that means that increased at a rate of 590,000 per year. Okay, next we're going to look at the average rate of change of a function. So let x1 and f of x1 and x2 and f of x2, which we can see here in the picture, or in the graph, be distinct points on the graph of a function f. The average rate of change of f from x1 to x2 is going to be f of x2 minus f of x1 divided by x2 minus x1. Okay, so let's look at an example. So finding the average rate of change. Again, it's the average rate of change for f of x equals x cubed from x1 negative 2 to x2 0. So what we're going to do, our average rate of change, like we just wrote on the previous page, is f of x2 minus f of x1 divided by x2 minus x1. So Our x2 is 3. So f of, not 3. What did I say? Hold on. Our x2 is a 0, of course. So f of 0 minus f of negative 2 divided by 0 minus negative 2. Okay, now we need to plug in the f of 0 and f of negative 2 into here. So x cubed, 0 cubed, minus negative 2 inside the parentheses cubed. And then we can just distribute this 0 plus 2. Okay, 0 cubed is 0. Negative 2 cubed is going to be negative 8. And 0 plus 2 on the denominator is going to be 2. So a negative and a negative, that becomes a plus, and 0 plus 8 is 8, so 8 over 2 is going to be 4. That is our average rate of change. Okay, that's it for this lesson. Let me know if you have any questions. Bye.